Recreate that bracket today and put it to the test. So we'll do some destructive testing. We'll measure the amount of force it takes to break both prints and both orientations, and see what we get. So let's hop on Fusion here real quick and get something drawn up. Now, I don't have any measurements for this or whatever, so I'm just going to sort of eyeball it, and we're going to get as close as we can, but it should really prove the point either way. All right, we're in Fusion here, and we're going to get started. So I measured a brake line that I had laying on the shelf, and it was 0.27 inches. So we will do that, 0.27. All right, so that is going to be our brake line hole, and then we just need to make another one of these, so we can just move and copy. Make sure and click Create Copy, and we'll move this over. Again, I'm just going to have to eyeball this because I don't have measurements off of the original part. So we're just going to move that 0.6 inches. And then now what we can do to get the curve that follows this outside edge is we can do an offset. And we will offset by 0.075. And we can do the same thing on this one. 0.075. Then now we can just kind of connect with lines. So we'll start here and there. Now let's go ahead and make that tangent. There we go. Now that forces that to be right on that tangent edge, and we'll get the rest of these lines in place. So now we can come in here and do vertical. This makes this straight up and down. All right, I don't know if this is going to work, but let's try the tangent down here. Okay, that does work, so that's good. And to keep things from moving around, let's make this horizontal. Then now we can make this vertical, which will make that straight, make this vertical, makes that straight. And I think we're in pretty good shape there. So now we can get rid of some of this that we don't need. So come in here to trim. We can trim this piece out, and this piece out, this piece, and this piece. Okay, so you can see we have the basic shape here of that part, and now we just need to extrude for the thickness. So we'll right click and extrude. And then I have a screw here that's going to be what holds it together and holds it down. It's as close as what I have on the shelf to what was in the picture. And the head is 0.39 inches thick, or in diameter. So I think we'll make this whole thing 0.415. And that gives us the what looks like the part in the picture. So now we need to put a hole right here. So we'll come up here, the hole command, click this face because that's where we want it. And now let's get right on it so we can get the hole in the right spot. Now if you click here, you can move this and you see that white dot, that is the dead center. So that's kind of nice, it puts you right there. Now an M6 screw in American measures out to 0.3. So to have a little bit of clearance in there, we'll go 0.35. So come over here, 0.35. All right, and then for distance, if we do all, then that makes it just go all the way through the part. So if we decided later we wanted to make this thicker, the hole's just gonna go with it, but we're not getting into things that complicated today. So we will just be done with that there. And now you can see we have what looks like the part in the picture. So the only thing we have to do now is cut it across here. So let's move this a little bit. And we need to do an offset construction plane. So we'll do offset plane. We want it to be offset from this plane, so we click that. Now if we get over the top of it here, we can just drag this right to the middle. So it's kind of not letting us hit that dead on, so we'll just have to type something in that gets there. And there we go, 0.21 right in the middle. And now that we have that, we can split body. So we'll select this body. Now we will need to move this a little bit so we can see what we're doing. Now splitting tool will be that offset plane we just made. We hit OK. Now we can come over here and move body 2. There we go. Now you can see we have as close as I can get to what that picture was without having any kind of measurements or anything. So we're going to get this exported out to the 3D printer, and we're going to print this in both orientations at the same time, so that way they use the same print settings and we can see which one of these is stronger. So off to the 3D printer we go. Alright, 3D prints are done, so let's take a quick look. One thing you probably noticed that there was 4 in the time lapse. From the time that I started this video until I printed, someone had mentioned doing 2 other angles, mostly just kind of to see what would happen, not that there was any chance they'd really be any stronger. One of them actually broke apart trying to just get the support material off of it, the one that was standing up, which, yeah, nobody would look at that one and think it was strong enough anyway, but we were just going to try it. Since it broke, I wasn't going to print another one, but we got 3 here. Okay, so while editing this video, I realized that I didn't do a very good job of explaining some of these orientations and also how I tested it. So this is the build plate showing how these were all printed. This over here was how the original image was printed, and this was my suggestion of a better option. These other 2 were added in just to kind of see what happened, and it definitely was much more difficult to print, and you needed supports and things like that, where these other 2 didn't need that. So then for the testing, what I did was I had a bolt that went through here, went through both of these, and bolted to the piece of square tubing that you'll see. And then I made a hook that went into the brake line hole and just pulled straight down this way. I used a floor jack to basically lift the square tubing, and then had a ratchet strap pulling down to the front of the floor jack, so that would add the pressure. So hopefully that clears all that up, and I really meant to cover that better in the video. This was sort of a last minute video, and usually kind of plan this stuff out a little bit better. But now let's get to the testing. So this first one was printed on like a 45-degree angle, and it doesn't really look that good. And if I tried harder, I could probably make it look better. But it's just still really not the right way to do it. This one was printed in the orientation of the image, and you can see, if we can get it to focus here, see, it just looks kind of rough. And this one was printed the way that on its side, and so you can see the finish is a lot better. And these were all printed at the exact same time with all the same settings, the same filament and everything. So now we're gonna put them on here with a scale, put some load on them and see where they fail. All right, so you can see we got about 4 pounds on here. It's kind of the least weight I can put on it with this setup. I was gonna try to do 0, but it's just not possible. Let's start jacking on this floor jack and see what we get. That's quite a bit of weight on that first one. I didn't expect that much. Let's go ahead for the second one and see what we get there. All right, so this is the next one that's printed in the same orientation as the image. So let's give this a shot. So unfortunately, I didn't realize that the scale had switched to kilograms, and so that's why it was, showing 43 and not, higher like it should have. It works out to, I think, about 94, 95 pounds, something like that, which is pretty surprising. I didn't expect any of these things to go this high, even the one I thought was going to be the strongest. So let's go to that one now and see what we get. All right, so this is the piece that was printed on its side, and which I expect to be the strongest, but we'll see what happens. All right, so that's pretty surprising. The diagonally printed one was actually the strongest, and I didn't expect that. I thought it would be pretty close to the other one, the one that was printed like it was in the picture. But that one really surprised me, and they were all really close together. I didn't think they'd be that close together, and I didn't think they would all go as high as they did. So hey, you learn something new every day. I definitely do, and that's a big reason why I wanted to do this. I was pretty certain I was right that printing it on its edge was going to be the best way, and it turns out that for the finish, for all around quality of product, that definitely is. It's a little bit stronger than printed the other way, but both other methods just don't produce as nice of a quality visually. So you take this for what you want. If absolute strength is everything you're after and you don't care what it looks like, put that thing on a 45-degree angle and have at it. I don't know if I ever will do that, but I know that it works now, and I might if I have something that needs that kind of strength. Otherwise, I'm going to stick to what I thought was going to work because it gave the best visual quality and also pretty good strength, where the weakest one out of the bunch was the one printed like in the image. So, like I said, take that for what you want. And if you have any other ideas for things like this, I'm not trying to be a 3D printing channel, but I just like to give information on the stuff that we do as car guys. So if you've got any ideas, let me know, and I'll try to work it into a video. But for now, that'll do it, and we'll see you in the next one.